My dear students and listeners, warm greetings. So now I'm going to give a short lecture on a topic called Introduction on Consolidation. It is one of the topic comes under Unit 3 of CE22301 Soil Mechanics. So myself, Dr.S.Hariswaran, Assistant Professor, Department of Civil Engineering. So I would like to give a small intro. So what is meant by consolidation? Why we are supposed to study this consolidation? It is nothing but expulsion of water from the voids in a saturated soil, that is called consolidation. Due to the applied or static loading, this type of consolidation settlement going to occur. You can see this picture. It purely demonstrates why these things we are supposed to give a more care before execution of any construction. Means this a small pictorial representation exactly explain. Once, if we constructed any structure which constructed above the water, maybe the type of soil, without any pre-treatment or without any assessment, if you constructed, execute any the construction means, the soil may undergo settle because of compression of soil particles. This compression may be or maybe due to the expulsion of air or expulsion of water from the voids. That is okay. If we are just because of the sudden application of the load, if we face uniform settlement in that area, all the area of the building is equally settled, no issues. It will never, no structural member undergo any problem. Whatever the performance we are expected, we can expect. Only the thing, whole building going to get subside down. When we will get problem means in a second one, irregular or differential settlement. One part of the building undergo higher settlement, another part of the building undergo a smaller or lesser settlement. This differential settlement create more bending moment on the all bending members, horizontal as well as vertical members also. It may undergo a different stress distribution, bending distribution, everything it will affect. Ultimately, the start with a small crack. The further development of settlement, more distortion of the building occurs. Ultimately, it leads to the distress in the form of very large differential cracks. So we have to calculate what is the possible consolidation settlement of a soil on which where we are going to construct. That too, we have to make sure about the distribution of the soil below the ground surface. The soil profile we have to assess. If there is any presence of higher thickness of the clay, we have to give a more care. That too, if one extreme end have a very lesser thickness of the clay and another extreme of the building having a higher thickness of the clay, means we have to give a more care regarding consolidation settlement. One side higher thickness may undergo higher consolidation settlement. The area where having a very lesser thickness may face a very smaller consolidation or consolidation settlement. So we have to give a more care on that. So that is why that consideration of consolidation characteristics very important in the aspect of all geotechnical engineering projects. The best example of this type of uh, uh, one of the wonder leaning of Pisa Tower. Why this happens? We are categorizing this as a wonder, but technically this happens because of irregular settlement of the soil below the structure. You can see the right side here. It shows the demonstrate the layers of the soil present well below this. Here there is a presence of a different clay layer. Whenever there is a presence of clay layer, we can expect consolidation settlement. Consolidation is means it will never take immediately. It purely time dependent. Based on a type of clay, based on the permeability characteristics of the clay, based on the drainage condition, the time it take for getting 100% consolidation will be differ. It's maybe of just a days, just a month, just a week, or just a month, or just a year, maybe more than a 10 to 15 or 30 years. It will depends on different type of soil. So Your knowledge on this is very much important here. So yeah, this picture exactly represent what is meant by consolidation. As per the soil mechanics, we are differentiated in a three-phase diagrams. One is soil solids, another is voids. In that void, there may be two phases of soil may occur. Two phases of material may occur. One is water or voids. This is only possible to available in a void space. One is water, another is air. Now, due to the applied loading, you can see the second picture. Now we are talking about consolidation. Consolidation is nothing but it's happened only in a saturated soil, that too fully saturated. There will be no presence of any air. All voids are occupied by water. Also, consolidation takes place. The difference between compaction and consolidation, every engineer must aware. Compaction is an artificial thing. By applying a dynamic load, we are removing the air from the voids. That is called compaction. How much energy we are giving? The equivalent compaction effort we can expect. In case of consolidation, in case of clay soil, we can't able to go for dynamic loading. Once we are giving a dynamic loading, the possibilities of expulsion of water from the voids we can't expect in a faster way. It is purely time dependent and permeability characteristic dependent. So consolidation is nothing but when we are giving additional load due to the static loading, the pore water present in a voids undergo higher stress. Water is always try to transfer energy or always try to dissipate its energy. Slowly it finds a path to escape from the soil voids, and slowly it coming out. The flow or velocity of movement of soil we indirectly calling as a technical property is called coefficient of permeability. If the soil having a good or higher permeability due to the applied load, that excess pressure carried by water can be dissipated as soon as possible. In case of the clay, the permeability is very low. Sometimes people call it as no permeability, very low permeability. In that case, it takes more time to dissipate that additional pore water pressure carried by the additional stress applied on the soil. So it is purely, that is why I'm highlighting, it is purely time dependent. This picture you can see, once due to the applied load, the height thickness of the soil going to get reduced. That is called settlement. It is nothing but consolidation settlement. Due to this, some amount of water is expelled out. That equivalent amount we can get subsidence. So that is called consolidation settlement. It is a purely time dependent. The stress applied is not going to change. Like construction of the building over a type of soil is called as consolidation. The building weight is same. The stress transferred is same for a continuous process. Now, once the stress is applied, the pore water pressure is going to getting higher value. Or whatever the pressure we have applied, the more pressure will be transferred on the soil. That pressure slowly dissipates through the expulsion of the water from the voids. So, time. If the time is keep on going on, based on the time, the excess pore water pressure slowly it dissipates. After certain time, the time may be differ, maybe 1 day, 1 week, or 10 week, or 10 years. Ultimately, that pore water pressure going to get zero. Because of the applied load, there will be no any additional pore water pressure got generated. If that pressure is getting zero, then at that moment we can confirm the consolidation settlement is achieved. That is 100% is consolidation is achieved. There will be no any further consolidation settlement going to occur. So how can be differentiated in the aspect of effective stress? Once a load is applied, the load will be taken by excess pore water pressure. Then when moving of time, this excess pore water pressure is going to get reduces. All the load will be taken by soil particles. So effective stress is slowly increasing. After a certain time, whatever the additional stress applied, all the stress will be taken only by soil. At that moment, pore water pressure U equal to 0, total stress is equal to effective stress, sigma is equal to sigma bar. Initially, once we have applied, pore water pressure increases, effective stress is initially 0, totally slowly it is increasing, then settlement also slowly increases. After a certain time, it's going to get ceased. There will be no any further change in settlement. That is called consolidation. This is a exact overview of consolidation. So let me describe what are the different tests available in the laboratory. So if I would like to forecast about the future's consolidation, then I have to take the soil sample from a site. This can be achieved by carry out any one of the site investigation technique. I suppose to explore the soil sample from that exact location taken into the laboratory, and I have to conduct this one-dimensional consolidation test. I supposed to conduct in the laboratory. There may be two types of mold is available. One is floating ring, another is fixed ring. So in that sample is placed here, then above and below filter paper supposed to be placed. Then at the top and bottom porous stone supposed to be placed. We are going to apply a load through this loading bar. A load will be transferred as a stress. Then stress will be transferred on the soil sample. Because of the stress mechanism, the soil is going to undergo compression like this. This compression indirectly confirms that consolidation. Because of this compression in two directions, the water is allowed to escape in top as well as bottom. So indirectly we are calling this as a double drainage system. If water is allowed to escape in only one direction or one surface, we are calling it as a single drainage. If water is allowed in both sides, we can call it as a double drainage. If there is a presence of double drainage, the time taken for 100% consolidation will be less compared to the another case, single drainage. If single drainage means only one side water going to escape, whatever the water particle present at the bottom, it's supposed to travel to the whole thickness of the soil to the top drainage, and it's supposed to escape. So time taken for 100% consolidation may be purely depends on permeability of the soil as well as drainage condition. So this test can be conducted. How can this can be achieved means a dimension of soil sample is of just 20 mm. The diameter of the soil sample generally 2 times 5 centimeter will be provided, that is 50 mm sample. Then once a load, a stress increment can be achieved by loading bar. Initially at rest condition. At rest condition means natural condition. In exactly at the site, the soil sample where I am extracting, I supposed to observe what type of soil present above that region. If I just take the soil sample exactly at 4 meter depth, imagine that 4 meter depth of the soil create a stress over that sample whatever we are taking. So first I have to create such load. That is technically we are having 3 different terms. One is normally consolidated, another is called over consolidated, another is called pre-consolidated. When we are calling it as a normally consolidated means if a soil it undergo higher stress than that of whatever the stress what we are applying now. For example, a soil sample because of 2 meters depth of soil, it already undergoes some pressure. That may be X. I just take the soil sample and kept in the laboratory and I just applied very small load. There will be no change because already that soil sample have experienced a 2 meter thick weight of soil. So now we can call it as this is a over consolidated soil. Already it got consolidated. When we can say normally consolidated means the 2 meter thickness, whatever the stress, it must be same stress we have to apply. Then only it started to behave compression. That is called normally consolidated soil, right? So such test we are supposed to execute by changing the behavior will be keep on change. If I just apply a small stress, initially the soil sample having a thickness of H0 approximately 20 mm, it have a void ratio of E0, It is the initial sample the characteristics. Because of the applied load, the soil may undergo compression. Because of the compression, slowly water going to keep on dissipate. After some time, that dissipation of the water going to get ceased. Indirectly, we come to know that is 100% consolidation occurred for the applied stress. Now, what we have to do is we have to increase the stress, another stress. Now, initially it is E naught. Now, at the end of the first loading, we are getting some change in thickness. 20 mm may be getting into the 19 mm. 19 point some fraction also possible. We are having a good least count dial gauges using in a laboratory. The thickness, change in thickness is observed. Void ratio also changed. So E naught becomes E1. Now I just applied the second load. Once again it undergo compression till it undergo 100% consolidation for the second increment load I have applied. Right? Now E1 going to become E2. H1 become H2. Some more compression is keep on changing. So we have to observe n number of changes. Then only we will get some characteristics which can be observed. So this was already detailed in the classroom for better understanding. I just once again recalled this a small recorded presentation. Here you can see water may be of the clay or sand. This is the first loading. The dial gauge reading is keep on changing based on the time. After 24 hours, after 2 days, 48 hours, the trend of a curve is going to very flat. The slope will be become very flat. There will be no much changes. Then we have to go for a next loading. Like for each loading, we have to observe H0, then H1, E0, E1. For a next load, I have to for a next load increment, I have to must aware regarding what is the initial void ratio, what is the final void ratio, what is the initial thickness, what is the final thickness. Like that, I supposed to plot a graph between effective stress and final void ratio for each loading. For EF1, for a sigma F1, I got EF1. Then for a sigma 2 second load, I got EF. Like that, we have to conduct n number of load increment. All the points are connected together by a smooth curve. Then I have to draw this type of curve. From the curve, what I am going to observe is different parameters we are supposed to observe. The first one is called coefficient of consolidation, AB. It is nothing but slope of the E versus sigma plot. Whatever the value we are retrieving from here, the same can be plotted in E versus log sigma plot. That in a log sigma graph we can plot it, we will get somewhat compared to that we will get somewhat good slope, easy to measure the slope. So this slope is called as compression index, right? The behavior of the clay will be purely differ when it is loading and then unloading and then reloading. So in the loading stage we are getting a curve like this, then unloading stage, then reloading stage. The slope of the curve will be totally differ. So based on that we are having a different term. Whatever the slope we are observing from the loading is called compression index. Whatever the slope we are measuring from unloading is called expansion index. Whatever the slope we are observing in a reloading is called recompression index. C, E, C, R. Three terms will be there. You can see here, this is a coefficient of consolidation. This is change in void ratio by change in effective stress. Y-axis by x-axis, like tan theta, slope. Here, representation of AB in terms of negative, because void ratio is reducing, falling gradient. The next term is called coefficient of volume change. That is a definition. Volumetric strain per unit effective stress. Then there is a relation between change in height, change in volume and change in void ratio. Del H by del H naught, del V by V naught, del E by 1 plus E naught. So based on this relation, instead of MV, MV is equal to minus del V by V naught, we can substitute, instead of del V by V naught, we can substitute del H by H naught, also del E by 1 plus E naught. When we are substituting this two term, we may get different parameters. Del H is equal to minus mv into H naught into del sigma bar. It is nothing but del H means change in height. We can make use of this characteristics to study the consolidation settlement and the real-time field condition. In real-time field condition, if the clay layer having a 5 meter thick, we know that based on the laboratory measurement, if you are aware on MV value and what is the stress applied on the soil, the stress may be due to additional stress, may be due to the placing of any large equipment or construction of any buildings or any large liquid storage tanks, water may be. So we are able to find the settlement. Instead of this del V by V naught, if we are substituting del E by 1 plus E naught, we will get another type of value. Then slope of the curve in E versus log sigma plot is called del E by log base 10 sigma divided by sigma naught. That is final stress divided by initial stress. You can see log base 10 initial stress plus additional stress by initial stress. The same thing in here. Based on thumb rule, a scientist arrived based on n number of established results. They have come out with the relation between liquid limit. Compression index is equal to 0.009 into liquid limit minus 10. Right. So there is a relation between MV and AV based on introducing some changes. Multiplying by del E and dividing by del E, we will get a relation between these two is MV is equal to AV divided by 1 plus E naught. Coefficient of volume change is equal to coefficient of compressibility divided by 1 plus E naught. Then whatever I have mentioned, the slope of unloading is called expansion index. The slope of reloading is called compression index. The same, but the value may be different. Instead of del V by del V naught, if you are applying in that equation, we will get the formula del H is equal to H into Cc by 1 plus E naught log base 10 initial stress plus additional stress divided by initial stress. This is the formula for arriving settlement. So in a next recorded version, let me share what is meant by consolidation at all. So I also explained regarding what is normally consolidated and over consolidated. A term is introduced called over consolidated ratio, that is past pressure divided by present pressure. Right? If the past pressure is higher compared to the past pressure or present stress we have applied, then OCR value will be more than 1. Indirectly we come to know, or indirectly we can confirm that soil is over consolidated. If the both values equal, then normally consolidated. Then another case is available under consolidated soil. OCR value is less than 1. It is practically impossible to takes place. That is, if you are recently filled soil, based on the recent fill, the soil itself undergoes slowly get compressed. So that category we can call it as under consolidated. So consolidation settlement, how to arrive? In practically, you can see here, for example, there is a 2-3 layers available: sandy layer, clay layer, sandy layer. That clay is present in between sand. So due to the applied load, once the load is applied, the sand going to settle immediately. That is what we can say that sand always gives an immediate settlement or elastic settlement we can say. But clay only undergo consolidation settlement. You can see I just constructed some building. That building gives some stress distribution. The stress maybe have some slope. Exactly how I supposed to arrive the consolidation of this clay means I supposed to consider a center layer. Center layer, what is the additional stress imparted by the load? So how can we arrive this means whatever the stress exactly at the surface, that is to be converted into load. Then that load is constant which is act on the surface. the area distribution is going to get higher. At the bottom, at the height, we know the slope, so we are able to arrive what is the extended area. The same load but extended area, the stress going to get reduced. That is the additional stress which exactly acts on the clay. Then we, with the help of this formula, if we know the CC and E naught value of the clay, we are able to find the change in settlement or consolidation settlement by using the formula log based in initial stress plus additional stress divided by additional stress, initial stress. What is initial stress means? Sigma naught. Exactly at the center of the layer, whatever the stress imparted by this soil present above that layer is called initial stress, right? So there is a derivation of one-dimensional consolidation equation. So whenever we are having a clay, there is a presence of sandwiched by two sand layer, a chance for drainage to escape in both direction. What we are doing is we are considering a small strip of soil and we are arriving different characteristics how the discharge will take place when it is entering and when it is exits. Based on that, we are arriving this differential equation k by gamma w dou square u by dou z square is equal to mv into dou u by dou t. Now all the constant term, coefficient of permeability k, gamma w and coefficient of volume change, these three can be clubbed together and mentioned as CV, coefficient of consolidation. Dou square u by dou z square equal to dou u by dou t. This is CV is nothing but coefficient of consolidation. This is the term we have to arrive based on the laboratory test. Laboratory consolidation test, we have to arrive this value. Everybody must aware on this formula, coefficient of consolidation CV is equal to k by gamma w into mv. Right. The next thing is called degree of consolidation. Now we know the clay going to undergo consolidation. Now I just apply the load on the structural load on the soil. It undergoes slowly compression. After 1 year or 2 year, I would like to know whether the consolidation is totally completed or not. Or initially based on the calculation, I may arrive that the total consolidation may take place after it may take 3 years or 3.5 years, like that we can confirm. Exactly after 1 year, how much percentage of consolidation was occurred, like that we can able to arrive. That is called degree of consolidation. Degree of consolidation. You can see here, as I mentioned earlier, if the clay above and below in both sides, we are having a good possibilities of permeability, like sand is there, the soil, water may be escape in both direction. So exactly at the end of the clay layer, the pore water pressure is 0, and exactly at center, the pore water pressure is maximum. At T1, initially the pore water pressure is maximum, then time occurs based on if the time is keep on going, that the stress, maximum stress at the center going to reduces. After certain time, that pore water pressure is 0. Then we can confirm that consolidation is 100%. Unfortunately, one side we are having a sand, another side we are having a rocky surface. Then water will never flow in rocky surface. Then at the bottom, in this case, at bottom we are having a higher value, and at the top, pore water pressure is 0. So the drainage, the direction of the drainage helps to confirm the percentage of consolidation. How much time it take to get 100% consolidated. To coin this term, we are having a two definition. Degree of consolidation is nothing but ST by SF. ST is nothing but settlement at the time. SF is nothing but final settlement. That is the maximum settlement the soil may undergo due to the applied load. ST is nothing but settlement after some time or at present. So settlement at any time divided by final settlement is equal to into 100. If you put, we come to know what percentage is settled. If the building or if the soil going to get settled by 10 centimeter is already predicted, but now 3 centimeters already got settled. Indirectly we can arrive 3.5 divided by 10. 35% of consolidation is got occurred. Like that we can confirm. In another way, the settlement is indirectly we can define by U, pore water pressure. Once the load is applied, pore water pressure will be maximum. At the end of consolidation, pore water pressure is 0. Now, initial pore water pressure minus pore water pressure at present condition divided by initial pore water minus pore water pressure. This final pore water pressure is 0, so we are not taken and considered. So UI, initial pore water pressure minus pore water pressure at present divided by initial pore water pressure into 100, we can arrive the degree of consolidation. So degree of consolidation is totally depends on time. So that is what we are introducing a term called time factor TV. Time factor is nothing but CV into T by D square. CV is nothing but coefficient of consolidation. Time is nothing but time of consolidation for 100% get consolidated. D is the effective thickness of the soil. So what does effective thickness means? If clay, we are having a clay, that is a thickness called H. That is a H. If you are having the drainage possibility in both direction, top as well as bottom, the thickness may be considered as a half, because whatever the water present here will be dispersed in a top, if this portion will be dispersed in this direction. So the thickness, half of the thickness can be considered. H by 2 is called as D. If there is only one drainage, one side is rock, another is direction is called sand, means we have to consider a whole thickness as the effective thickness of the soil. So Terzaghi arrived the relation between degree of consolidation and time factor. If the time factor is less than or equal to 60%, the relationship is like this. TV is equal to pi by 4 U by 100 whole square. If U value is more than 60%, the relationship between T and U is 1.781 minus 0.933 log base 10, 100 minus U. Whatever the value we are supposed to substitute U here is in terms of percentage, not in fraction. We have to substitute as a percentage. 30% means we have to substitute here as 30. If U is less than or equal to 60, if it is more than 60, we have to make use of this relationship. Hope a short lecture give a more confident on understanding of consolidation, why we are considering, what are the different aspects we have to consider, what are the parameters which influence. So everything was covered in the short lecture, so it will be more helpful for you. So thank you. Let us meet once again in another occasion. Thank you.